Alright, welcome to another video lecture. So today we're going to talk about two areas, adding, subtracting, and multiplying the radical expressions, and the other area is going to be rationalizing the radical expressions. Okay? Alright, so what we talked about the last time, let me just hang on a second here. I might have to, I don't know what's going on there. Hang on a second. I want to make sure that my voices are being recorded here. So I think it is. All right. So, last time we talked about the rational exponents. Adding, using all these laws of exponents. Now we are applying to the rational exponent, and the rational exponent is simply the you writing the radical expressions, using exponent with the fractions. Okay, so we should be able to apply all the laws of exponents that we have, and then rewrite them using rational exponents, and then use the laws of exponent to simplify them. We also talked about a little bit on the multiplying the radicals, but we'll talk about that a little bit more today. And then we also have some property of the radicals. We talked about that. So if you have radicals on top to bottom, you can just combine into one or vice versa. Okay. We also talked about the if you have a different radicand inside with the different index, you should be able to do that, but for the kind of limited way. So using all that, so we're going to go into the other area, and the let's just look at the adding and subtracting and multiplying, and then rationalizing the radical expressions there. Now let's just go back to the understand that if you look at the like square, like you got something like this. Let's say cube. Let's say 3x or something like that. Now what we have here is the number here. The 3 is going to be what we call index. Okay. And the quantity is inside here is called the radicand. Okay. So if you want to add and subtract, you have to have both same radicand and the same index in order to add and subtract. Otherwise, you won't be able to add and subtract at all. Okay. So that's the one thing that we need to be careful when we add and subtract. Okay. You can make the radicand same, and that's going to be the process that you have to go through if you need to. Okay. All right. I'm going to show you a quick example of what you can do and what you cannot do when you have the radicand. Okay. So here's an example. Let's say we have. I'm just gonna put it over here. Now, if I have square root of 3 plus the square root of 2. Now, in order to add and subtract, you have to have the same radicand and the same index. Now, in this case, we do have same index, square root, right? Same index, but different radicand. So that means we cannot do anything. So that's going to be the simplest form. So that would be a one case that you were not able to do anything when you, in terms of adding and subtracting, the radicals here. Now, the other one will be something like this: square root over 3 plus the, let's say, cube of 3. Now here we have same radicand, but we have a different index. Okay. So that means you cannot add these two radicals. Okay. So these are the two cases that something, some operation that you cannot do. Here's a, but you're gonna have to look carefully inside the radicand. So let's say, what about if I have something like, square root of 12 plus the square root of 3. If you look at this one as it is, they are, even though they have the same index, their radicand is different, so I won't be able to add these two. But that's not true though. That's why you want to rewrite the radicals as a small base as possible. So here, you're going to have to rewrite the square root of 12. Okay? So if I rewrite the square root of 12, I have 2 times 2 times 3. Then I have plus square root of 3. So now these two can come out as 1, 2. So you have what? 2 square root of 3 plus the square root of 3. Now we have same radicand with the same index. So this just 2 simply means that you got 2 of those, right? So now this can be added as a 3 square root of 3. So because you have a different, radicand, it does not always mean that you cannot do the operation. You're going to have to rewrite the radicand so that you're going to have to make sure that, the radicand itself is different. If you can somehow rewrite them, and then you see that you have the same radicand, then you have to do that way. All right. So here's the something that the numbers. If you have just the number inside the radical, that'll be fine. But sometimes you got mixed. Okay. So I'm just going to show you. What if you have mix of constants and variables? So if I have like 3x, then we have a square root of 20x minus 7 square root of 5x cubed. So if you just look at this as right now, there's nothing you can do because the over here square root of 20x is 20x, on the over here it's 5x cubed. But as I said, you're going to have to rewrite this, okay, using the smallest radicand inside possible. So I'm going to rewrite them. See if we can come up with the same radicand. So 3x times, now remember that the 20 is going to be 2 times 5x. And minus 7. Now if the 5x cubed, we can write as 5x times x times x. So as you can see here, the 2 2's come out as 1 2 outside, and then these 2 x's come out as 1 single x. So let's just take that out. You got 3x times a 2. Then you got square root of a 5x minus 7. Then square root of, but before you can do that, I am going to take out the x in the front, so you got minus 7x and square root of 5x. So here on the left hand side, I have a 6x square root 5x then I have a minus 7x, then square root of 5x. So now we do have a same index with the same radicand. You see right here. Okay? So that means that, you know, when you have the radical, you simply adding, subtracting the quantity. So you got 6x over here, minus 7x over here, so you got minus x. Square root 5x is going to be your answer. So, you know, just make sure that, you know, you don't make any mistakes by not making the radicand, you know, small as possible to compare, see if they have, you know, at the end, you know, see if you end up with the same radicand on the radicals that you have. So the let's just make sure that when you add and subtract, okay, you know, we're going to make sure that, you know, in order to add and subtract the radicals, you have to have the same radicand and the same index. And if it doesn't appear to be have, you know, same index, I mean the same radicand, you know, try to make it simple as possible. See if you can determine whether that you need to you know, do the operation or not. Okay, so there are some other ones that, you know, we're going to look at here. So let's look at another one. So what if I have something like this? I got cube root 16x to the fourth minus 7x cube root of minus 2x plus cube root 54x. Now, if you see this right now, then there's, you know, I mean, the only thing that I can tell you is that, you know, they have cube root for all three terms. So that's the only thing that, you know, I am going to have. But the radicand is all different, right? So we're going to have to somehow rewrite the radicand and see if we can come up with the same radicand so we can do the operations here. Okay, so give me a second. Sorry about that. All right, I think I missed the few. Okay, now I'm gonna have to go back here. I don't know how far I went there. Okay. Yeah, I think let's just go back and redo this exercise. I think I cannot turn off my a microphone here, and I don't know how far I went back. I think it's about here. Yep. Okay, so let me try over here. Yep. Okay, so what we just did here is that let's just go through the example, this one again. Sorry about that. I don't know, I forgot to turn on the microphone here. That was my mistake. So let's just go over this. Okay, so here I have a 3x, square root over 20x minus 7 square root over 5x cubed. So I write the square root. So 20, you can rewrite it as a 2 times 2 times 5x. Then you have a 5x times x times x. So that's what the x cubed is. So once you take that out, 2 to the front and x to the front, you get 6x square root over 5x and minus 7x square root over 5x. So now you have a same, the radicand. So now you should be able to combine the quantity in the front. So you got 6x minus 7x. You got minus x square root of 5x there. Okay. Next example that I did was cube root of 16x4 minus 7x cube root of minus 2x plus cube root of 54x. Again, we wrote the radicand. So 16 is going to be 2 times 2 times 2 times 2, and we have 4 x's here. And on the last term, we got 3 times 3 times 3. Okay. So these 3 2's come out as 1, 2, and 3x is going to come out as 1x, and these 3 come out as 1, 3. So we were able to combine the first term and the third term because they have the same index with the same radicand. The problem was that the second term over here. And the second term is that I explained it up here that you can rewrite the minus 1. If you rewrite that minus 1 3 times, you're going to get minus 1. So you can just take that out to the front, and that's what we have. Oops. What we have in front of that cube root, which is a minus 1. So minus 1 times the minus 7x, that gives us the positive 7x. Okay. So we were able to combine those, okay, but only thing that we were not able to do here was that because of this one has the 3, not 3x, we could not combine this one, but we were able to combine these two radicals because they contain both cube root and the 2x in this case, which is the radicand there. Next example that I showed you was that sometimes you need to change the radical into the rational exponent. Now this one on the left hand side, if you look at the m4, it come out as 1m, so that's all right. But over here, if you look at the n square, and you got the index of 8, so this will not come out from this radical. And remember that the index is going to be always at the bottom, okay, right here. So we were able to rewrite the radical into the rational exponent. So 2 divided by 8 is going to be 1/4. Okay. If you rewrite the 1/4, that's the fourth root. So now you have both first term and the second term have the same index with the same radicand. So all you have to do is just take care of the quantity in the front. Okay. Now, when you multiply the radicals, I mentioned that when you multiply them, when you multiply a radical with the actual, just the number, you do not want to put the number inside the radical. You just multiply them. Okay, so in multiplication, we don't have any restrictions on the radicand. Okay, as long as you have the same index. Okay, so that will be fine. Unlike the adding and subtracting, if you look at the example that we just did previously, we don't really do anything to the radicand once it is the same. You're just taking care of the quantity in the front. But that's not what's happening when you multiply the radicals. You actually multiplying the radicands. But if you want to multiply the radical with the number, the regular number like this, then you don't put it inside. So if you multiply in this example, square root of 5 times 3, you get 3 square root of 5. And then, when you multiply square root of 5 times 4 square root of 5, so now you're multiplying 5 to 5, which gives you 25 there. And every time you multiply, whatever, you always want to make this radicals as small as possible. So obviously the square root of 25 is going to be 5. So 5 times 4, you get 20 minus 20. And that's going to be the simplest form that you can have. Now, same thing for the if you multiply the cube root. Okay, exactly the same as the square root. Make sure that if you are using the cube root, then you have to have exactly 3 numbers of variables to take them out. Okay, so in this case, you got 3 cube root of 2 times 3. You get 3 times the cube root of 2. And if you have a cube root of 8, you get 2. So this is going to be the simplest form. If you're going to multiply the two terms one another, I want you to use the table. So here's a 3, 2 square root of 7, and the 2 minus 3 square root of 7. So 2 times 3, you get 6 over here. And 2 times 2, you get 4 square root of 7. And if you multiply 3 times minus 3 square root of 7, you get minus 9. And 2 times minus 2 square root of 7 times minus 3 square root of 7, you get minus 6, 7 times 7, right? So if you rewrite this, you will get something like that. So you can combine the middle term over here, 4 square root of 7 minus 9 square root of 7. Then again, square root of 7 times 7, it becomes a 7, right? So you got 7 here and minus 6 over there. And combine the 4 and minus 9, you end up with the minus 5 square root of 7. Now you can combine the constant, 6 and minus 42, you get negative 36. And minus 5 square root of 7. I apologize for the mute for about, I don't know, 10 or 15 minutes. I'm sorry about that. I didn't realize that my microphone was off. Okay. So you just kind of, you can kind of, you can just go through it without, hearing me. Then again, when you come down a little further, then I'm going to speak it again, okay, with the same thing. All right, so now the next thing that we want to look at is something called the rationalizing radical expressions. Okay, so let me just write that here. Rationalize, not that one. Okay, so rationalizing radical expressions. We want to do this just for the denominator. Okay. What we mean by the rationalizing is that when we have any type of radical expressions, we don't want to have the radical square root or cube root at the denominator. So we want to get rid of it. Okay. So that's going to be the process of what we have here. Now, for example, let's say we have some sort of 1 over square root of 3. Okay, now we don't want to have a square root of 3 at the bottom there. So what we mean by the rationalizing here is that you're just going to multiply top to bottom by exactly the same quantity. The reason is that, because if you multiply the exactly the same thing, you're going to get 3 times a 3, it come out as a 3, right? So on the top, you got square root of 3. Then the bottom one, you got square root of 3 times a 3. Obviously, this come out as 1, 3. And the square root of 3 over top. So as you can see, the bottom denominator, we don't have radicals. Okay. Now, if you have the cube root, it's a little bit different, because if I have, let's say, a cube root of 3. Now remember that cube root requires the exactly identical 3 variables of the numbers. So in this case, you're going to have to multiply the whole thing top to bottom by, right, cube root of 3 times 3, or 9, right? Because in the denominator, now if you rewrite them, you got cube root of 3 times 3 times 3. Although on the top, you're going to have 3 times 3 though. Okay? So on the top, you're going to have cube root of 9. But at the bottom, these 3 3's come out as 1 3. Okay? So now you see that you don't see the radicals at the bottom anymore. Now, as long as you have one term at the bottom, like 1 square root or things like that, you're going to be fine. Okay, you're just going to multiply the exactly same amount. But sometimes it's going to be a little bit different here. So let me just show you another one. So if I have something like square root of 5 over square root of 12. Well, here the only way that we're not going to multiply this by square, I mean, you could, you can multiply this by square root of 12 here and square root of 12. Then you will have a square root of 60 divided by 12. Then you're going to have to rewrite the square root of 60 and so on. But there's, you can just, we always want to multiply the smallest number, so that after the multiplications, you want to, take it out from the radical, because if it's going to be smaller number, it's going to be much easier. So in this case, I'm probably going to multiply by square root of 3, top to bottom. Why? Because I know exactly what the square root of 36 is. Okay, so here's going to be square root of 36. On the top, it's going to be square root of 15. So you got square root of 15 on the top, but square root of 36 is going to be just a 6. I mean, you can still do with the square root of 12. That's all right. But sometimes you do have to use the small number there. What about if you have the variables at the denominator? Okay, so you got 3 square root of 2x. So same thing here. You're going to have to multiply, in this case, by square root of 2x. Okay, same thing. Top to bottom. So on the top, you will have a 2 square root of 2x. At the bottom, you're going to have 3 times 2x. Okay? You can cancel out the 2 over here. You have a square root of 2x divided by 3x. Okay, and that should be the answer. Now the problem here is that what if you have two terms? We just talked about the single term at the bottom here. So now what if you have something like square root of 2 divided by square root of 6 plus 2? What if you have something like that? Well, we are going to multiply the top to bottom by what we call the conjugate. What that means here is that we are going to multiply the exactly same thing, same two terms over here, but opposite sign. So that means we're going to have to multiply this by square root of 6 minus 2 and square root of 6 minus 2. So I'm going to show you, use the box here, and we're going to rewrite the after the box here. So if I have a box, okay, oops. So I have square root of 6 plus 2 and the square root of 6 minus 2. So that will be a square root of 36, 2 square root of 6 minus 2 square root of 6 and minus 4. So square root of 36 is going to be 6 plus 2 square root of 6 minus 2 square root of 6 and negative 4. But if you look at the middle term, they cancels out. And if you just combine the 6 and negative 4, you're going to end up with a 2. So the entire thing at the bottom here after the multiplication is just going to be a 2. Then again, you're going to have to multiply the top though, right? So you'll have a square root of 12 and minus 2 square root of 2. Right? So we're going to have to do some housekeeping here. Square root of 12 is going to be what? 2 times 2 times 3. So 2 come out. Okay, then it's going to be a square root of 3. Then minus 2 square root of 2 divided by 2. And the numerator, you can just take out the common factor of 2. Okay, then you got square root of 3 and minus square root of 2 divided by 2. Then you can cancel out the 2. Okay, so your final answer is going to be square root of 3 minus square root of 2. Okay. So the one thing that if you have two terms at the bottom, okay, you might want to always think about the what we call conjugates. So in this case, if it's going to be plus, you just do the exact multiplying the exactly same thing, but sign is going to be opposite. So this example that I showed you had the one radical at the bottom and one the whole number at the bottom. What if you have the both bottom? The bottom is the radical is at the bottom there. So let's just take a look at that one. So I have a square root of 6 minus 3. Then divided by square root of 10 minus square root of 6. So here, just like the one we just did, we are going to multiply as conjugate. So bottom here, when you look at the bottom, it's going to be square root of 10 minus square root of 6. So we're going to do exactly the same thing but different opposite sign. So you got square root of 10 plus square root of 6, and same thing up here, square root of 10 plus square root of 6. Now you're going to have to use the a table here. So let's just do the table at the bottom one. Okay, so I'm going to draw the table here. Okay. So I have a square root of 10 minus 6, square root of 10 positive 6. So here the first one is going to be square root of 10 times 10. I have a minus 6 square root of 10, positive 6 of square root of 10. Then I have a minus 36. So square root of 10 times 10, that's just going to be 10. I have a minus 6 square root of 10 plus the 6 square root of 10. And then I have a minus 36. So as you can see, the middle term drops off. Okay, that's why we are multiplying by its conjugate, so we can drop the middle term. And then if you simplify the 10 and minus 36, we're going to get negative 26. So the bottom one here is nothing but minus 26. We have to do the same thing for the top, so we're going to do another table box over here. Okay. So we have what? Square root of 6 minus 3, square root of 10, and the square root of 6. So square root of 10 times the square root of 6, we got square root of 60, minus 3 square root of 10, square root 6 times the 6, then I have a minus 3 square root of 6. Let me rewrite this. So you got square root of 60 minus 3 square root of 10. But if you multiply, if you have a square root of 6 times a 6, they come out as a 6. Then I have a minus 3 square root of 6. So the only thing that, when you look at it, we can combine, rewrite the 60 with what? Square root of 2 times 2 times 15. There's nothing I can do on the square root of 10, plus 6 and minus 3 square root of 6. So this radical in the first term, we can have what? 2 square root of 15 minus 3 square root of 10 plus 6 minus 3 square root of 6. And there's nothing else we can do to this radical terms because everything is pretty simplified. So that's going to be on the top. So this is not unusual that you will get something like this. So you got 2 square root of 15 minus 3 square root of 10 plus 6 minus 3 square root of 6. Okay, so that's going to be our answer here. Okay, all right. So I want you to practice a little bit on this, and make sure that rationalizing, you're always going to be multiplying top to bottom by is a conjugate. Exactly the same thing, but it's a different opposite sign. Okay. So next video, I am going to go over the couple of topics, the radical equations and the complex numbers here. Okay. Again, I want to apologize for the mute section in about 10 minutes. I didn't realize that my microphone was off, so you're probably not going to hear anything. But after I realized, I kind of went over that area again, so you're probably not going to miss anything. Okay? All right, thanks for watching, and I'll see you in the next video. Okay, Bye-bye.